So in this section, we are basically simplifying rational expression, correct? And then we worked on number 1, number 2, and number 3. And each case was different, all right? So number 1, we're going to take it one at a time. So 4x squared over 2x squared plus 3x. And we are told simplify the rational expression if possible. So we're going to lay it out, and then we're going to separate the numerator, which we did here, 4x squared, and we're going to split it. So that's 4 times x times x. And then the denominator is 2x squared plus 3x. So now the greatest common factor here is x, right? Here. And then if you pull out the x out of 2x squared, you're left with 2x. And then if you pull out the x out of the 3, you're left with 3x, right? So it's x parentheses 2x plus 3. And now you rewrite the expression as 4 times x over x times 2x plus 3. And then now you can simplify the like terms, which is the x, and you're left with 4x over 2x plus 3. Correct?
Yes.
Now the next one was this one here. X squared minus 2x minus 15 over x squared minus 4x minus 5. And remember, we worked on this like last year, how to factor these kind of second degree equations. So now we want two numbers whose product is negative 15 and sum is negative 2, right? And we wrote on the corner here, we have 3 and 5. 3 times 5 is 15. Now, how do we work on this number so that their sum gives you negative 2 is what we are looking for? So negative 3 plus 5 gives you positive 2. That's not going to work. But negative 5 plus 3 is negative 2. So that works. So we go back and we rewrite the expression as x minus 5 and then x plus 3. That's for the numerator. And then for the denominator, we repeat the same steps. We want two numbers whose product is negative 5 and sum is negative 4. And you immediately found 5 and 1, and 5 minus 1 is 4. Or negative 5 plus 1 is negative 4. So that's the better digits. So we go back and we do the same thing. We replace it, and then we rewrite the whole expression as x minus 5, x plus 3, x minus 5, x plus 1. And then we cancel out the like terms, and we are left with this. And the last problem, we had x squared minus 16 over x squared plus x minus 12. Now this is different. This is the difference of two perfect squares. So we recall the formula. A squared minus b squared is a minus b times a plus b. And then we're going to apply that here with x squared minus 16. So that will give you x minus 4 and x plus 4. And then we take that and we work on the denominator. We did the same step that we did previously. We broke down the denominator, and we want two numbers whose product is negative 12 and sum is 1. It was 4 and negative 3. We rewrite the whole thing, and then we go ahead and simplify the expressions. Okay? Easy enough, right?
Yeah.
Okay, now you're going to work on your